thing you do when you're in a programming environment is you actually type in code. So if I was going to actually type in code, I would do it just like I was using a word processor. We call this Okay, so basically I am now typing in C++ code, and I'll of course give you a problem tomorrow to type in. And after you type in the program, okay, this process of typing in the code is called editing. So the first step in the process of creating a program is called editing. And it's very much like using a word processor, but I don't have all the, I don't change the font, I don't underline, things like that. But basically I create text, okay? So this is called using an editor, and this basically just creates a text file. So this is given to you in this Visual Studio environment. Now, if I compile this project, what does the compiled, well, we talked about that, didn't we, briefly last week? What does it mean when I compile a program? Colin? Okay, so compiling translates the program that I wrote to what? Machine language. Why is it necessary to translate a program from C to machine language? What do we say about machine language? What do we say about machine language? The only language a computer can understand is machine language. So every program I write, if I use C, if I use Java, if I use BASIC, if I use Perl, must be translated to ultimately be in machine language. Okay? So one of the things that compiling does is translate it from that language to machine language. Okay? Now let's say that I make a mistake in my coding. What do we call that when I make a mistake in my coding when I'm editing and I try to compile? Jared? This is called a syntax error. Okay? Why do we call that a syntax error? What does syntax mean? Syntax is the rules of the language. If I do not follow the rules of the language, the compiler will not know how to translate it. Okay? So the syntax is things like spelling of the keywords, using a semicolon, which in this case I did not. I made a syntax error. Now, the nice thing, which you might not think is nice, when I go to compile this, what's compile again? Translate. When I go to compile this, I look down at the bottom and it says that there was an error, syntax error, missing semicolon before return. Okay? And at first you look at these errors and you don't really understand what they mean. Now let me give you one tip, which is if I double click on the error, what happened? What happened when I double clicked on the error message? My cursor went up to somewhere around where the error was. The error is actually on the line before, but it goes up to where the error is. Okay, so what should I do then? I should put the semicolon back into the line, compile again, And it now says that it worked, there were no errors. Notice that you have to look at everything down below to kind of see what's happening. This time it says the build succeeded. Okay? If I now would like to run this program, and these steps will all be written for you tomorrow in your navigation sheet. You're going to say start without debugging. And this exciting program did what? It printed hello. It printed hello. So I've got 3 screens going on here that you're going to need to start becoming familiar with. This is the screen that has my file. This is where I'm doing my what? Editing. Okay? This screen down here shows me the results of my compiling and attempting to execute. So error messages will appear down here. This screen here is really your output window. It shows you the results of what the program does. Okay? So after you compile and translate, you then must run your program to see what it actually does. Okay? And this program simply printed hello to the screen. So cout therefore must do what? What must cout do? Displays or prints to the screen. Okay? And the other overhead sort of comes with the program. Okay. So that is the, and I'm going to get back to the slide. It's what we call a structured programming language. And that was the first paradigm for programming. Now remember, computer science is new. I mean, it's not like biology and physics, you know, we didn't have age-old philosophers creating computer science. We had hippies in the back of garages creating computer science. And matter of fact, a lot of us wrote programs before computer science was really even an official science. You know, we didn't learn it in college. We just kind of wrote a bunch of stuff. Okay? So computer science came a little bit after the fact. And the first paradigm that was created was called the structured paradigm. And it was designed to say, here's a good way to write programs. There's some rules and a structure for writing programs. And the structured paradigm is pretty much what we're going to follow in this class. We're going to learn the structured paradigm of programming. Okay? Whatever that means, which you'll get. Okay? Now, I'm going to come back to the structured paradigm. But the structured paradigm was, in a sense, make a little bit of a switcheroo here. We're not just going to take the nouns just like they're in a program. Like, we're not going to say, if somebody says, you know, user's ID number. We're not just going to write user's ID number. Since our job here is to come up with a programming solution, we're going to start treating this as a programmer would. So we're going to define variables from the get-go. What the heck is a variable? What the heck is a variable? Any idea? Location where stuff can be stored. V, you want to add to that? Okay, but I'm surprised somebody's not saying something else. Way to store data, these are all correct. But what about that name, variable? What else? You can't add anything based on that? It can change, right? So a variable is a place to store data that can change. Okay? So rather than just copying from the problem nouns and adjectives, we're going to define variables. And I'm going to give you some rules, and people usually like rules. So we're going to use the rules of C. Why not? That's what we're using. So we're going to use the rules of C from the get-go to define our variables in our input and output columns. Now, here's the rules of C. A variable has no spaces. So that means that if I am talking about room length, I cannot say room space length, because what did I just say? No spaces. So what would be a better name for room length than room space length? And in C++, we tend to use capitalization, which we call Camel Case. Okay? In C and C++, variables begin with lower case. In C++, the convention, not the law, not the rule, not the syntax error that you will get from this, this is called convention. Do you understand the difference? It's what they do. It's what they use. The compiler's not going to squawk at you. It's just convention. If you want to be cool, you use the convention. Okay? If you want to be employed, you use the convention. Okay. So room length should start off then as room length. And of course, I just did this in the video, can't see it. Let me see if I can scoot over before I have to. Wrong way. Oh, so annoying. Sorry. Anyway, we call this, let me pull this in, too far. We call this Camel Case. I still don't think you can see this on the video. Let's see, I'm moving here, room length. Okay, so Camel Case means what? We start off with lower. If we want to do a second word, we go to the capital, and that's the camel's hump, la, la, la. Okay, and if we can even do this with 2 or 3 words. Each new word is an uppercase letter. We call that Camel Case. Okay. Meaningful names. What the heck do I mean by meaningful names, and why should they be used for variables? True. And what do we say? He said, so whoever's reading it or writing it can understand what the variable is. And what do we say most of coding is done? Maintaining existing code. So if most coding is writing existing code, be a good coder and use good names for the future, which may be you. You may be the one coming back changing it. Or somebody else who's going to speak very poorly of you if you give it some stupid name. So what's the definition of a good name? Well, I always tell students use the perfect name. Not too short, not too long, just meaningful. I mean, you can use well-known abbreviations. Okay, why is item price better than price? It's more specific, right? I mean, price could be anything. Okay, sales tax rate. So we don't want to make them 5,000 letters long. Why not? Because who's typing that? You sucker, right? Okay. So not a million lines, just something that's concise and readable and understandable. Okay. So this takes practice. All right. Begin with lowercase. Here's some examples. Room width, num people, student name. Student name is better than name because it explicitly says it's the student's name, and we use camel case in each one of those. Okay. So we're going to use this for all the input and output data. Okay, bring the